Hello! So we're going to go over chemical reactions. So this is Physical Science Unit 3, Lesson 2. So what is a chemical reaction? A process that involves rearrangement of the molecular or ionic structures of a substance as opposed to a change in the physical form or a nuclear reaction. So what exactly does that mean? So a chemical reaction is the change of a substance into a new one that has different chemical identity. So we talked about the physical and chemical changes. So now we're looking specifically at the chemical changes, and we're taking one substance and making it into another. So some indications of a chemical reaction. So changing in properties, so that's density, smell, taste, texture, melting and boiling points, hardness, etc. So we're going to see that change. We're going to see that change in color. So if you look over here, you can see how we have a blue liquid that's being poured and is reacting into a yellow liquid. We have emission of heat or light. So that's like the atomic bomb down here. Gas production, not boiling, but actually the production of gas. So you're seeing that in this picture here. So we have a substance down here in the flask. We have a couple pipettes that are dripping down and it's causing a reaction that produces this gas. And the last one is the production of a precipitate. So if you look at the bottom picture here, you have two clear liquids, and when we pour them together, you actually get this solid that is forming from the chemical reaction. So reactants and products. So the reactants are what go into the chemical reaction, whereas the products are what come out of the chemical reaction. So if you look at the picture here, we have our reactants on the left and the products on the right. Remember to look at that arrow, because the arrow is always going to be pointing towards the products. So you can have it in the space-filling diagrams like here that show the bonds. So single and double bonds. Or you can have it written out. So here's another way you can look at it. So here, of course, we have the physical states that are listed. You don't have to worry about writing those down at the moment. That's something you're going to have to do when you get into the high school chemistry and the higher up levels. You have your coefficients. So we have our actual formulas here. The arrow, so you have your reactants, and then you have your products. Or you can look at it this way too for the space saving. So you have your two hydrogens. So you have two hydrogens. So here is one set of two, the other set of two. You have one set of two oxygens, and then when they react, they split apart and reconnect, so they reconfigure to have two molecules of H2O. So one oxygen and two hydrogen. Here's just another way you can look at it. So once again, your reactants are over here on the left, your products are on the right, and you're just looking and seeing that rearrangement. So instead of having it wrote out for 2H2 plus O2, we're now looking at H2, H2. So we broke that apart so you can see how it relates to the atoms. Alright, so types of reactions. The first one is our combustion reaction. So you must have O2 as a reactant. So if you don't have O2 as a reactant, it cannot be a combustion reaction. So your decomposition reaction is one reactant splits into two or more pieces. So you're going to see you have like one reactant and you might have two or more products. You have an exothermic reaction, which gives off energy during the reaction, and most of the time that energy is heat. Burning gas is exothermic. So if you think about why your car engine gets so hot, it's because when the pistons are firing and it is firing and the gas that's in the engine, it's actually exothermic. So all that metal is heating up, and that's why you need your radiator to help keep things cool. So endothermic takes energy to perform the reaction. So it actually has to take energy from the surrounding area in order to get that reaction to get even started. And then endothermic is kind of like baking a cake. So you have to put that cake in the oven and ordinary for that reaction to occur, for them to all bind together and actually go from the individual ingredients to that cake. And when you're looking at endo and exothermic and you're trying to remember which one is which, one little tip that I've used in the past is that think of an ant. So ants have an exoskeleton. So that exo means on the outside. So when you see exothermic, it's pushing the heat to the outside. So it's giving off that heat. So let's look a little bit more at the combustion reactions. So we know that it has to have O2, so oxygen, as a reactant, and it's almost always exothermic. There's only a couple rare cases where it's not exothermic, but for the most part, you're going to see energy being released. So this is just a generic one. So if you have wood and the presence of oxygen, you can burn it and you get coal and you get heat off of that. So anytime you burn anything, you can feel that heat coming off, and that's because it's a combustion reaction. So this is actually rubbing alcohol, and you're going to put it with oxygen, and then when it actually combusts, so you can actually burn it off, you're going to get CO2, which is carbon dioxide, water, and heat. So another way to make sure that you're getting a combustion reaction is that you're going to see CO2. You're going to see CO2 as part of the products. So the general one here, you're going to have some sort of carbon-hydrogen combination. So X and Y can be any numbers in a certain ratio. Then plus your oxygen, and you're going to see that you're going to have carbon dioxide and water as your outputs, but you're also going to have heat, remember. So you're going to have heat there. So X and Y is going to be on a ratio, and then you're always going to have the oxygen, and you're always going to have the carbon dioxide and water. So products and combustions are always carbon dioxide and water, although sometimes they can be incomplete, so you might see like carbon monoxide instead of dioxide, but you're still getting that carbon-oxygen combination. And combustion is used to heat homes and run automobiles, so we just talked about the gas earlier. So this is a couple examples of the combustion reactions. So the first one here, you just make sure that everything has to be balanced, because remember we talked about nothing's created or destroyed. So we have 5 carbons on this side, and then because of the 5 coefficient here, we know we have 5 carbons on this side. On this side we have 12 hydrogen, and then 6 times 2 gives us 12, so now we know we have 12 hydrogen. Here we have 8 times 2, so we have 16 oxygen. So here's where we have to do a little bit of math. So 5 times 2 gives us 10, plus the 6 times 1, so that's 6. So 10 plus 6 gives us 16, so that is a balanced equation. So we're going to write the products and balance the following combustion reaction. So we have C10H22 plus O2. We need to know what it's going to give off. So we know that CO2 is always going to be a product. And same thing with water. So that is what this equation is showing. But now, is that balanced? Well, let's look. On the starting side here, we have 10 carbons. On this side, we only have 1. So we know we have to add a coefficient of 10 here. So now we have 10 carbons on this side. That matches with the 10 carbons on the reactant side. But now that also changes the oxygen here. So 10 times 2 gives us 20. So right now we're at 20 for oxygen. But if we look at hydrogen real quick, we see on this side we have 22 hydrogen. So we need to have 22 on the right-hand side or the product side. So 1 times 2 gives us 22. Well, that's 2 times 11, so we have to add the 11 here. So we need to count up the number of oxygen on the right so we know how many we need on the left. So 11 times 0 is going to be 11. And then 10 times 2 gives us a 20. So we have 31 on this side. But 31 is an odd number, so we can't have that odd of a number. So now we're going to have to relook at our coefficients and see if there's anything that we can change. Well, one thing we can do is actually add. We can put a 2 in front of this one. So now that's going to make this be 20 and make this one 22. So that's going to make this 40. And now this here, instead of 11, is going to be 22. So now that we know that we have 62 oxygens on the right, which is an even number, why did we need to have that even? Because over here on the left, it's O2. So whatever we have in front, we have times by 2 to get the same number as the number of atoms of oxygen on the right. So if we cut this in half, we get 31. So 31 would be on this side for oxygen. So we have 2C10H22 plus 31O2 yields 20 CO2 plus 22 H2O. Alright, so let's look at some decomposition reactions. Alright, so one compound splits apart into 2 or more pieces. They can be elements or simpler compounds. So the generic reaction is you have molecule AB, it reacts and splits apart into molecule A and molecule B. So if you look at the picture down here, we start off with an egg. It reacts, so now we have the egg shell plus the baby turtle that was inside. So if we start looking at these different type of decomposition reactions, you see the first one here isn't balanced, so we have to add the 2's in here to balance that out. Here we have H2O. We can actually react that to get H2O2. However, that's not a balanced equation, so we have to balance it. When we balance it, we can get 2H2O yields 2H2 plus O2. And then MgCl2 actually just breaks apart into Mg and Cl2. And FeS breaks apart to Fe and S. Alright, so now let's look a little bit more into those exothermic reactions. So an exothermic reaction occurs when the temperature of a system increases due to the evolution of heat. So this heat is released into the surroundings, so you can actually feel that heat coming off. So think of like any types of fires when you're burning, you can feel that heat coming off. So those are exothermic reactions. And that's why even if you are having a beaker and you're having an exothermic reaction go inside, you can actually feel the glass of the beaker get hotter and hotter. And that's one reason you have to know if your experiment is going to be exothermic, so that you can take the precautions not to handle hot glass. So in the endothermic reactions, those occur when the temperature of the system increases while the surrounding system loses heat. So that is, the reaction is taking in heat, so you won't feel it get hotter, but that doesn't necessarily make it feel like you're the glass is going to get colder when you're doing the reaction inside of a beaker. It just means that you have to add heat in. So a lot of times those are the ones we have to have like on a hot plate or things that you could do like on your stovetop. So the system of reactants that absorb the heat from the surroundings is an endothermic reaction. Okay, so what exactly does those two things really mean when we're looking at a reaction? So if you look at the exothermic reaction, so on the bottom, so on our x-axis, we have reaction progress. And then you get here on the y-axis, you see potential energy. So that would be like the amount of energy that it needs for the reaction to occur. And so if you look here at exothermic, we don't have to go up from the reactants to the products. We're actually going down. So you're actually having some of that heat give off into the surroundings before you can get to your products. Whereas you look at endothermic reaction, your reactants are below your products, so you have to add heat to your reactants to get enough energy to produce your products. So when you see a graph with the reactants higher than the products, you know that's an exothermic. And if you see a graph with the reactants below the products, that's going to be endothermic. Alright, so this is just going to show you a couple other reaction types. So synthetic is kind of almost similar to our combustion, but its combustion is a little more specific. So you see we have element A plus element B equals the combination of AB. And then we have the decomp. So AB breaks apart to A and B. We have single replacement, which we didn't really talk about, but that's basically you start off with AB plus another element C, and that rearranges to A, then matches up to C, and then B is the free element. Or you can have a double replacement, so you have AB plus CD yields AC and BD, so they kind of switch partners. So, if methane reacts with oxygen to produce carbon dioxide and water, what are the products? So when you're looking at something like this, first look to see what is reacting with which. So in this case, you have methane reacts with oxygen. And then look for those key words. Produce is the key word here. So now you know that everything before that is your reactants. Everything after that is going to be your products. And that's the carbon dioxide and water. So you're going to have methane plus oxygen yields carbon dioxide and water. So carbon dioxide and water is going to be your products. So in a chemical reaction, water decomposes to form hydrogen and oxygen. What is the correct term for water in this reaction? So we know it's a decomp reaction, and we know that we are going from water to hydrogen and oxygen. So it's H2O yields 2H2 plus O2. So we know that these are our products. Well, one is another term that we can use for water. If it's not the product, it is the reactant, because it's on the left-hand side. Alright, so which of these would be the best description of a chemical reaction? So before you read the answers, think about what we already discussed a chemical reaction, what we already discussed the definition of being. So then have that in the back of your mind and then read the options. We have mixing two substances, the combustion of a substance, forming or breaking bonds, or the decomposition of particles. So we know that you can mix two substances and not have it form a chemical reaction, so we can get rid of A. And then I know we talked about combustion and we talked about decomp, but those are specific types of reactions. So it's not like every combustion reaction is a decomposition reaction and vice versa. So those don't really talk about chemical reactions as an overall. So overall we see the breaking or forming of bonds, because that's how we get those rearrangements. So the correct answer here is C. So name 3 things that you must have in a chemical reaction. So think about when we write out a chemical reaction, what do we call each side? So if we have A plus B yields AB, we can call A plus B what? And we can call A B what? And then what else do you need? So think about the other reactions that we talked about. So we talked about endothermic and exothermic, and those both have to do with energy. So you need reactants, products, and energy to have a chemical reaction. So which one is a true statement about exothermic reactions? So energy from an outside source is continuously being added. A reaction container always feels cold. The reactants have more heat energy than products. More heat is given off than is put into the reaction. So first, stop and think about what exothermic is. So exothermic means that the system is making too much energy, too much heat, and therefore is pushing that energy out so you can feel the heat coming off of it. So we know that the energy from an outside source is not continuously being added because it's making its own energy, so we can get rid of A. And then B, if we have an endothermic or an exothermic reaction, the container is going to heat up, so we have to be careful of that hot glass. So we know B is not exothermic. Now, C and D, they're close, but you have to be careful about what each of those vocabulary words mean. So C, you have the reactants must have more heat energy than the products. Or D, more heat is given off than is put into the system. So if C, it's not necessarily that the reactants have more heat energy. So it's not necessarily they're going to have more energy. It's just when they react, they're going to give off extra energy. So when the best answer out of these two would be D, because that is more of a general overall statement for all exothermic reactions. So what is the term for a solid that forms when 2 liquids are mixed together? So here you see a clear liquid A, clear liquid B, and they form a solid. So what do we call that solid? It's our precipitate. So it's precipitating out of the reaction. So think of like the rain is precipitation. So this is a precipitate because it's coming out of that solution. So rain comes out of the clouds. So this is coming out of the solution. Okay, if you have any questions, please send me a K-mail. I do have several extra practice worksheets with answer keys on my website. So either it's a separate file or it's the second page of the file, so you can try it and then see how well you're doing. So basically, if you are having problems with these, you have to practice to get good at them. So even if you just go in and do 5 or 6 of the practice problems, that is definitely going to help you in the long run. So please make sure you're doing that. If you do have questions about balancing equations, I do have 2 YouTube clips. They are actually linked up with my website. So if you go to the extra practice worksheets and you look underneath Unit 3, you're going to see both the YouTube clips and all of the files for the extra worksheets. So please make sure that you're going and looking at them so you get a better understanding of how to balance those equations. And thank you so much for listening.